This is Friday's bell ringer. It says use the table to write the recursive rule, equation, and sketch the graph. So on my paper, I wrote the table. So we need to determine what the recursive rule is. So we need to determine what kind of function this is. So how can we decide if it's linear or exponential? We need to do the difference, find out what that difference is. So if I were to subtract these, I'm going to use calculator. And by the way, we are using these calculators on the EOC. So it's important for y'all, even though y'all have the other calculator checked out, to use this calculator while you're in class. So if you need to get up and get it now, go ahead and do that. You need to get one of these every day. One person from each table can grab them. So if I want to see if this is linear, then I subtract those. I do 9.6 minus 12. And it goes down by 2.4. And then the next one, 7.7 minus 9.6. It goes down by 1.9. So what does that tell us? Is it linear? No. So I'm going to mark these out, and I'm going to write over here not linear. Because it's not going down by a constant rate. So now I need to decide, okay, if it's not linear, then exponential, possibly. So to determine if it's exponential, you would divide these because it's 12 times something to get 9.6. If I'm going down, if it's a decrease, that means that my rate is less than 1. It's going to be a decimal that's less than 1. So I can divide these. Remember how we subtracted 9.6 minus 12? So instead of subtracting, we're going to divide 9.6 by 12. 9.6 divided by 12. It's 0.8. So that means it's times 0.8. Then we check the next one. Whenever we subtract, I did 7.7 minus 9.6. So instead of subtracting, I'm going to divide. 7.7 divided by 9.6. If I round that, isn't that 0.80 times 0.80? I put 0.8 here, I put 0.80 here. They're the same. Then the next one, 6 1400ths divided by 7/7. If we round this, this would be 0.80 or 0.8. And the next one, 4.9 divided by 6/14. So times 0.8. So that means that's our multiplicative rate, our exponential rate. So I'm going to write here, rate equals times 0.8. So the first thing it asks us is the recursive rule. So recursive rule, we are at start. How much does it start with?
12.
Yeah, 12. 12 is our 0. Our y-intercept. When x is 0, our start is 12. And then our recursive is going to be next equals now times what?
0.8.
Yeah, 0.8. But in math, I really don't want words in these equations. So the way you're going to start seeing this is with A's, because that's going to be using our A sub something. A with a subscript. So if it's our 0, our y-intercept is A sub 0 equals 12. So these two mean the same thing. Start is A sub 0, because that means x is 0 or n is 0. This is going to be on your test next week. Then the next one, a next, we're going to say a to the n, or subscript n, equals now, or the previous, times 0.8. We're going to change now to a to the n minus 1 times 0.8. This is how you're going to start seeing it. It's still times 0.8. So knowing that is going to make this a lot easier. Because if it's linear, it's going to be plus something or minus something. If it's exponential, it's going to be times something. Okay, the next thing, we did our recursive rule. So now it's the equation. So the general form for exponentials, because this is exponential, not linear, but exponential, but it is exponential, is a times b raised to the x power. So a is your start, and b is the rate.
Doesn't that change?
This will be the same. So now we'll plug in the numbers for our equation. It's always written like this: a times b raised to the x side. A is your start, b is your rate. So if I'm doing this equation, our start we wrote was 12. So 12 times the rate was our multiplying times 0.8 raised to the x power. So let's look at it on a graph so then we can sketch it out. So go to y equals, everybody go to y equals. Let's put this function in. So it would be 12 times 0.8 raised to the x value, or x exponent, x power. So when we graph it, so some things that you can look at is it's a decreasing function. It's going down, which that's what our table looks like anyway. Our rate is less than 1, so it should be decreasing. So now we are going to sketch it, where this is our x, this is our y. And what's our highest y value? What should I make sure that my y goes up to? What's the y max? Huh?
10.
It's like, well, here it's actually 12. On here, it's not right. So we need to go to our window and make our y max to be 12, which is our starting amount. So if we change that, we'll be able to see it on our graph. So I went to window, and I went to my y max because it's the y-axis. I want to see the y-intercept, which is 12. And you can go a little above if you want. Now hit graph. Now we know it starts there and then goes down. So on my sketch, I want to make sure that my max is 12. So I'm going to look and see 1, 2, 3, 4, 5. If I go up to this, I can go by twos. 2, 4, 6, 8, 10, 12. So I can graph it now. I know that 0 is at 12. Then I need to go here and go by ones. And I need to go to at least 4 because there's 4 on this table. And then 1, 9.6. So it's close to 10. 2, 7.7. So it's close to 8. 3, 6.14 is close to 6, and 4, 4.9, which is close to 5. And it's supposed to be a curve, so make sure it has a curve in it. It's going to go something like that. Because it's exponential, it's not a line, it's a curve. So in your test next week, you'll be given a table, and you'll have to match it to an equation or a graph or the recursive. So you have to know how to get from the table to the other parts.